Welcome to another video on control systems. In this video we will try to find how do we find transfer function of a system having it's being represented using block diagrams. So a system can be represented using block diagram. If it is represented so, then how do we find the overall transfer function of a system? Yeah, if you are ready, we will start today's lecture. Now let us consider the block diagram which is given over here. A system is being represented by this block diagram. First and foremost thing is of course, there is a way of finding the transfer function which we are looking at as CFS by RFS using block diagram reduction technique. We are not going to the details of that, but we try to find the same transfer function using signal flow graph. This is signal flow graph. Maybe in the coming videos we will see it as SFG. So we abbreviate it as SFG. Abbreviation of signal flow graph is SFG. So to convert a given block diagram to a signal flow graph, let us identify all summing point and takeaway points. So this is one summing point, let me name it as S1. So this is second summing point, name it as S2. This is third summing point S3. So this is one takeaway point T1. This is second takeaway point T2. Let this be the fourth summing point S4. Let this be third takeaway point T3. Maybe you can take this as another takeaway point as T4. So we are representing each and every takeaway and summing point along with the input and the output. So let us name all those, or let us consider all those summing and takeoff points as nodes of the signal flow graph. So we have RFS, this is S1, this is S2, third node is S3, this is, we're just writing in the same order as it is being named. So this is T2, then this is S4, then this is T3. Let me write this as T4. The location, let it be as it is over here. So between RFS and S1 I don't have any block here, so this is having a gain of 1. Between S1 and S2 there is no gain here, so it is again still 1. Between S2 and S3 I have G1, so let me name it as this path gain is G1. Between S3 and T1 there is a gain of 1. Between T1 and T2 I have a gain of G2. Between T2 and S4 it is G3. Between S4 and T3 it is again 1. So we have this part, and between this and this it is again 1. And okay, now I have this as my CFS, which is my final point. And you can see, let us now start connecting the things. From T4 it's going to S3. From T4 it is going to S3. The arrow mark is this way, and magnitude is H2, minus sign is there, it is minus H2. From the same T4 it is going to S2, the path gain is hardly 1, so it's minus 1. So it's going to this with a gain of minus 1. And then we have, okay, we are done with Are we done with this? So we are done with this, we are done with this. So from T2 it will go to S1. From T2 it will go to S1 with a magnitude of minus H1. So this is minus H1. And I have from T1 to S4. From T1 to S4. From T1 to S4 in this forward direction, the magnitude is G4. I think we are done with all of them. Now it is necessary to use the signal flow graph to find the transfer function using Mason's gain rule. So what does Mason's gain rule says? So as we explained in the previous videos, it is nothing but, let me just go back to the same definition. This is my M, which is given by 1 over delta k is equal to summation of k is equal to 1 to n pk delta k. So you have to identify the number of forward paths, and then after that it is getting this expression. So of course, what is delta? So delta is nothing but 1 minus sum of individual loop gains plus sum of gain product of all two non-touching loops. It continues that way. So let us do that over here. So let us know what is this M, which is given by 1 over delta summation k is equal to 1 to n pk delta k. So now in this case n is equal to, you have one forward path and there is a second forward path. So there are two forward paths. So then this M, which is nothing but RCFS by RFS, will be P1 delta 1 plus P2 delta 2 by delta. Now I need to identify what is forward path gain from RFS to CFS. Is it not? So what is the path gains? So it is 1 into G1, G2, G3. So it is G1, G2, G3. What is the second forward path? So P2. P2 is again moving from RFS to CFS. So second forward path is, you can go like this and then take G4 as its path and then go here. So is it not G1 into G4? First forward path is, it just goes like this and then goes through G2, G3. So that's what is G1, G2, G3, it is there. Then it is G1 into G4, so and so. Let us find the loops. So if you can see here, so of course you can clearly see that over here also. So one of the loop is G1, G2, H1, that is that gain is minus G1, G2, H1, so which is evident here also. Can you see here? So this is G1, G2 minus H1, so that's what is this. And the other one you can think of, start from here, go like this, and then this. So L2 is nothing but G2, G3, H2, and take it as minus. This is this is G2, G3 minus H1. So again L4 is, can we take this? It is G4 minus H2. It is minus G4 H2. So it is this. And then what else we have? Do we have this loop? See here, if I start from here, can I come back to this using this? L4 is G1, G2, G3 minus 1. So it is this G1, G2, G3 minus 1. So what is L5? Can you see it is G1, G4 minus 1. It is minus G1, G4. Any other loops? I hope these many loops are there. Then it is are there any non-touching loops? If you can see here, there are no such loops which doesn't possess a common node. Maybe you can write here the nodes associated with L1. So since we name L1 as this one, that is G1, G2 minus H1, shall I say the nodes associated are S1, S2, S3, T1, T2. This is S1, S2, S3, T1, T2. And then G2, G3, H2, it is G2, G3, H2, is it not? S3, T1, T2, S4, T3. So it is, these are the nodes. So it is G2, G3, H2, G2, G3, H2. So this S3, T1, T2, I am just writing the nodes associated with that. Of course, do we have this T4 also, because T4 is also coming. Then what is G4, H2? It is this. So you can start from here, go like this, go like this. So what are the associated nodes? S3, T1, S4, T4 coming back, and this G1, G2, G3, G1, G2, G3. So nodes associated are S2, S3, T1, T2, S4, T3 as well as T4. So these are the nodes associated. How about G1, G4? G1, G4, it is S2, S3, T1, T1, S4, T3, T4. If you can see these nodes, none of the loop has an exclusive node. So none of the two loops don't have exclusive nodes. So they always have one node or the other common. So since all the loops have one node or the other which is associated with the other loop, so these loops touch each other. These loops touch each other. Let me repeat. These loops have these nodes. None of the two loops doesn't have exclusive nodes. So all the nodes are there. At least all the loops have at least one node common to each one of them. So in such case, there are no two non-touching loops. So now what is delta? Delta is nothing but 1 minus individual loop gains. It is L1 plus L2 plus L3 plus L4 plus L5. So how about delta 1? Delta 1 is this is my first forward path. Are there any loops which are not touching this? If you can see, these are the nodes associated with the first forward path. So all the nodes are there in all the, of course, all the loops have at least one or more nodes associated with the first forward path. So this means that all the loops will touch first forward path. So there are no such loops which are not touching first forward path. That's why it is delta 1 is equal to 1 minus 0, which is 1. Same with the case as delta 2. So this is my second forward path. All the loops will touch the second forward path. So that's also 1 minus 0, it is 1. So now what is the expression for the Mason's gain formula? It is CFS by RFS. It is P1 delta 1 by P2 delta 2. So P1 is G1, G2, G3. Of course, delta 1 is 1 plus G1, G4 divided by 1 plus, because all these gains have negative, so minus of minus will become plus. So 1 plus G1, G2, H1 plus G2, G3, H2 plus G4 H2 plus G1 G2 G3 plus G1 G4. This is the final expression for the transfer function of this block diagram having the corresponding G's of hens. It's very simple. Identify different summing and takeaway points, mark them exactly as it is there in the block diagram, so don't alter the position, let it be there as it is. So you have this as the interconnection of those nodes, include their path gain, whether it is unity, G1, H1. Make sure that these signs of negative feedback, positive feedbacks are merged with this magnitude. Okay, then once you are done, it is identification of a number of forward paths, then their forward path gain, identification of loops and their loop gains, and of course this is just an indication that which are the nodes associated with each of the node. This will be helpful to identify the two non-touching loops. Of course you can do away with this also, because this is very clearly visible over here. So all the loops touch each other, means there are no two non-touching loops. Once you are done with this, next is use this formula of Mason's gain rule and try to get the overall final transfer function of the system. So this is the transfer function. Okay, let us see the next one. Just a minute. Okay, this is my second transfer function. So again we are supposed to find CFS by RFS. So let me identify all takeaway and summing points. So this is T1, S1, this is S2, this is T2. Okay, name this as T3, name this as, okay, let me name it as T4. The order doesn't matter. This is S3. So let me start. So this is my R, T1, S1, S2, so there's a corresponding T3 here, and this is T2, T4, there is a S3, there is a CFS. Now you start joining them with their gain. It is 1 between R and T, it is 1, then it is between T1 and S1 is also 1, between S1 and S2 it is G1, between S2 and T2 it is G2, between T2 and T4 it is G3, and between this and this it is magnitude 1, this is again 1. Then these summing points, so from T2 it will come to this with a gain of H1, and here it is -1, and then to this summing point it is again 1. Then from this takeaway point to this summing point, this takeaway point to this summing point, I have a gain of G4. I have a gain of G4, and from this T4 to S2. From this T4 to S2, this is my T4, this is S2 back. With the path gain, it is minus H2. Hope we are done with the signal flow graph. So this is done, this is done, this is done. Fine. Now it is necessary to find CFS by RFS. Let us write the equation, which is equal to m is equal to 1 over delta summation n is k is equal to 1 to n pk delta k. Correct? So since n is equal to, what is the value of n? So you can see this is one forward path, This is the second forward path. So n is 2. So it is P1 delta 1 plus P2 delta 2 by delta. So this is P1 delta 1 by P2 delta 2. So looking at P1, is it not, of course you can just have a look at this, G1, G2, G3 is my P1, G1, G2, G3. What is P2? P2 is, of course you start from here, this is G4. So this is G4. And how many loops are there? So one of the loop is this, which is evidently visible here. This is one loop. This is the second loop. This is third loop. When I say third loop, it is this. This is my third loop. And are there any other loops? So can I? Okay, I think those are the 3 loops. Okay, loop 1 is having a gain of minus G2, G3, H2, G2, G3, H2, and L2 is it is G2, H1 minus 1. It is minus G2, H1. What is L3? It is G1, G2, H1. It is G1, G2, H1. It is plus there. So these are the loops. And are there any non-touching loops? No, since we have only 3, so all these possess common node. Need not be, all nodes need not be common. Even if at least one node is common, it is touching. So what is M now? It is P1, which is G1, G2, G3, and its associated delta 1. That is, which are the loops which are not touching this forward path. So all the loops will touch that forward path. So it is 1 minus 0. How about delta 2? So this delta 2 is nothing but how many loops which are not touching this forward path. Actually all the 3 loops will not touch this. So it is 1 minus L1 plus L2 plus L3. So this delta 2. So this delta 2 is corresponding to this forward path. How many loops which will not touch this forward path? So this L1, L2, L3, none of the 3 loops will touch this forward path. So that's why it is 1 minus L1, L2, L3. So it is, now this is actually P1, delta 1 is 1 plus, what is P2? P2 is G4, but we have this 1 plus of G2, G3, H2 plus of G2, H1 minus of G1, G2, H1. Why it is minus of means because this is plus, minus of plus will become minus, whereas minus of minus and minus of minus will become plus. So these 2 terms are positive, whereas this term is negative. Divide by delta value. So delta value is 1 plus individual loop gains, that is G2, G3, H2 plus let me use this G2, H1 minus G1, G2, H1. This is CFS by RFS. This is CFS by RFS. Hope it's fine. Let us move on to next. So let us do it quickly. It's not at all difficult. So can we write the loops? This is T1, S1, T2, S2, T3, S3. So can we do it like this? RFS T1 S1 T2 S2, there's a T3, this is CFS, and there is one more S3, there's a S3. So do we have something like this? This is 1, this is also 1. Between S1 T2 I have G1. Between this and this it is G2, and I have one more thing which is going like this. This is G3, and from this T3 it's a magnitude of H1, and from that to summing point this S1 it is minus H2, and then from this takeaway point to this it is G4, this is minus G4, this is that T1 to is minus G4. So this is my third summing point. Now again, now Mason's-Gain rule, summation of 1 over delta, summation of k is equal to 1 to n pk delta k. So it is now how many forward paths? If you can see here, this is first forward path, this is second forward path, and this is third forward path. N is actually 3. It is now P1 delta 1 plus P2 delta 2 plus P3 delta 3 divided by delta is my expression for Mason's-Gain. So now can we write this P1, P2, P3 directly? So what is P1? Starting from here going to here. So is it not G1, G2? That is G1, G2 is this. And okay, let us try to find out what is, because what is the loop you have? So you have one loop like this, you have another loop like this. I think those are the two loops. How about this? So this is not a loop. What else? I think there are only two loops. So all the loops will touch all the forward paths. So all the deltas are 1, 1, 1. So delta 1 is equal to delta 2 is equal to delta 3 is equal to 1 minus 0, because there are only two loops. So first loop is minus, this is minus, okay. Is it not G1, G2, H1, H2? What is second loop? Is it not minus of G1, G3, H1, H2? So this is one loop. You can see here. I can come back to this loop. So from here it is G1, G2. This is the direction. I can come back to this, and another one G1, G3, H1 minus H2. It is this. There are two loops. So plus, okay, this is first forward path, and its delta is 1. Second forward path you can take it as G1, G3, and third forward path is minus G4 minus H2 G1. So minus into minus will become plus. Is it not G4 H2 G1 G2? Oh, actually we have 4. Okay, now it came like this. It's this, and you can go by this. So it's actually plus 1. So it is P4 delta 4. So what is the fourth forward path? Fourth forward path is start from here, go like this, jump this. So it is G4 H2 G1 G3 divided by the individual loop gain. So it is divided by, what's the gain? It is 1 plus G1 G2 H1 H2, and the other one is plus of G1 G3 H1 H2, and this is not a loop. So So this don't think that okay, this is minus G4 minus H2 and 1 will not become loop, because this is in opposite direction. Correct? This is the transfer function for this block diagram. Okay, fine. Let us try to find. So far we have looked at systems where there was only one input, one output. So all these were single input, single output systems, SISO. This is also SISO. This is also single input, single output, and this one is also single input, single output. So let us look at this, where we have two inputs but a single output. So it is MISO, multi-input, single output, multi-input, single output. When it is multi-input, single output, CFS can be written as transfer function 1 multiplied by the input RFS plus second transfer function TF2 multiplied by WFS. So when you consider this as the input, you have a different transfer function. When you consider this input, this is treated as 0, and when I consider WS as input, this is treated as 0. I'll have a different transfer function TF2. Now it is necessary to find what is TF1, which is nothing but CFS by RFS provided W of S is 0. Similarly, second transfer function is again CFS by W of S with R of S as 0. So let us try to find what is TF1, the first transfer function. For that, maybe we can certainly write the signal flow graph. What is the signal flow graph for considering this as 0? So can we write it directly here now? Because by this time now you are used to writing this equation, all those stuff. Let me write it directly. You can work out this way using Masson's gain rule, 1 over delta summation k is equal to 1 to n pk delta k, identify the number of odd paths and all those stuff. So let me write directly what is the transfer function for this one. Is this not a forward path? G1, G2, G3. G1, G2, G3 is a forward path and since you have only one forward path, so that corresponding delta 1 will be 1. Then the loops, so can you see this is one loop, so which is 1 plus G2H3. Can we see there is one more loop here? So this is one more loop plus G3H2. Can we see there is one more loop like this? Since it is plus, it's a positive feedback. It is actually minus G1, G2, G3, H1. So this is my transfer function. This is actually what? TF1. What is second transfer function? TF2. It is surprising to see, since the loops, non-touching loops won't change if you change the input from here to here, the denominator remains the same. So what is denominator? It is 1 plus G2H3 plus G3H2 minus G1, G2, G3, H1. So how do you reach this output from this W? It is only this is the possible way. So possible way is G3. This is G3 is a hot path. And are there any loops not touching with that? Yes, there is one such loop. Can you see? This loop does not touch with this. So it is G3 into 1 plus G2H3. 1 plus G2H3. So this is my transfer function. Suppose if you want to get the expression for CFS, is it not RFS multiplied by G1, G2, G3. Okay, denominator can have it as common, which is 1 plus G2 H3 plus G3 H2 minus G1 G2 G3 H1. So this is my denominator, which is common, and this is corresponding to RFS, and corresponding to WFS, it is WFS multiplied by G3 into 1 plus G2 H3. So this is my ultimate output expression. CFS is given by this. CFS is given by this. Fine. So this way you can able to write. So what I'm trying to do here is trying to find, there are two transfer function corresponding to this output and first input and second input. So this is what we are using superposition theorem. This is for linear time invariant systems, LTI systems, linear time invariant systems, for which you can apply the superposition theorem as we use in electrical networks. It is also applicable to these type of block diagrams. You have two inputs and a single output. The overall output due to both the inputs is given by this expression, and it is interesting to see that denominator of both the transfer function with only RFS, with only WFS remains same. The denominator, only the numerator will change. Let us see the next one. Okay, this is next. Okay, here this also you can write it. So can I write C1 of S as by considering R1 of S as the input. So now if I consider this as the input, okay, what is in the denominator? So let us try to identify the integer loops. Is it not 1 plus G1 G2? Is this one loop? Is this another loop? Plus G4. Are there any other loop possible? Can I just go like this, go like this, go like this, go like this? See here. Can I just go like this? It is G4, G5, H1, then G1, then come back. I think there is one more loop. Let us see whether it is minus or plus. Can you see it is G4, G5. This is, I just started from here, G4, G5, H1. This is again plus. This is G1. This is G1. You have to come back here. This is H2. Since it is positive feedback, everywhere it is positive, so this becomes negative. Then what else? That's it. So this. Are there any two non-touching loops? Yes, these two won't touch each other. That is plus of G1, G2 and G4. This is the two non-touching loops. Corresponding to R1 of S, the forward path is this. So it is what? G1, G2, G3 is the forward path. And are there any loops which are not touching with this? Yes, this loop doesn't touch. Is it not 1 plus G4? 1 plus G4 plus R2 of S multiplied by, what is the forward path gain? This is the path here. You can see I can reach this C1 of S from this R2 through this way, G4, G5, H1. So it is G4, G5, H1, G1, G2, G3. And are there any loops which are not touching with that? No, this loop and this loop, all of them will touch. It is R2 into only the forward path. So this delta is 0. Sorry, delta is 1 here. correct? Here it is G4, G5, H1, then G1, G2, G3. This is only for C1 of S. So similarly for C2 of S, C2 of S, the denominator is already obtained. This remains the same, because since the loops and the non-touching loops will not change whether you have input, whether you take the output here, take the output here, whether you have the input or not, it remains the same. It is same. It is 1 plus G1, G2 plus G4 minus G4, G5, H1, G1, H2 plus G1, G2, G4. This is the numerator, same as for C1. Here with R1 of S as the input, with R1 of S as the input, what is the forward path? Forward path is this, reaching this C2. Is it not G1? Is it not G1 into G4, G5, G6? See this? Reaching C2 of S from R1. Is it not G1? Oh, H2 is missing. Okay, G1, let me write H2 here. This is G1, H2, G4, G5, G6. Since all the three loops will touch that, so this is 1 plus of R2 of S multiplied by, so what is the forward path of this? Is it not this? Because I have to reach here, so this is a forward path. Is it not G4, G5, G6 is the forward path for C2 of S from R2 of S? And does this loop touch this forward path? This loop won't touch, so that's why I have 1 plus G1, G2. This will not touch this forward path, so I have this as the expression. So C1 of S, C2 of S is this. Denominator remains same because you have one loop, two loop, third loop and two non-touching. So that is 1, 2 non-touching loops. So it is actually, if I say this as L1, L2, L3, this is actually L1, L2, L1, L2. So this is 2 non-touching loops. Hope you got this idea. Thank you.